Okay, students, welcome to lesson 9 on seasonal variation. So we want to today calculate some seasonal indices by using the average percent method. We'll end up deseasonalizing a time series by using a seasonal index. And we'll show you how to do it, and then in class I'll give you a turn doing a spreadsheet. I'll probably turn that into a separate video as well. And then we can also solve practical problems that involve the analysis of time series data. So what do we see here? We see, first of all, something called a seasonal index. And a seasonal index is just found by dividing the data for the season by the mean of the data for the whole period of the time. So in 2016, down at Ashfield Road, we had 327 millimetres of rain in summer, so December, January, February, 139.9 in autumn, 238 in winter, and 224 in spring. Now, just to average them up, you add those four together and divide it by 4 because there's 4 numbers there. So we can say that an average season in this case has 232 millimetres of rain. Now, to calculate a seasonal index, what we're going to do is just get that original amount and we're going to divide it by the mean. And you can see that, for example, that summer we had 327 and we're dividing it by the mean. So we get a seasonal index of 1.41. In autumn, we had 139.9 divided by that mean of 232.4 to get 0.6, so 60%. Or 40% less than normal. And then winter 238 divided by 232.4, so that's pretty spot on, just 3% above. And spring, well, 224.2 divided by 232.4, so 0.96 or 4% lower. So we can just use this now to interpret that data. So the summer rainfall was 41% higher, because remember this is like saying 141%, so it's just 41% more. Whereas in autumn was 40% lower than the average season. Winter was 3% higher than an average season, and spring in 2016 was 4% lower than the average season. So the seasonal indices will have a mean of 1. So that means if we add all 4 of them up together, so 1.41 plus 0.60 plus 1.03 and 0.96, we should equal 4. So if we have a seasonal index, a question I might ask you is to calculate a missing seasonal index. So what must we do? We just need to recall that the sum of the seasonal indices should equal 4 because there's 4 values. So it's just going to be 4 take away 0.5, take away 0.1, take away 2.0, and that should give you 0.4. I could be a little bit nasty and throw some algebra at you, for example. In this case, we've got 12 bits of data. So the sum of the seasonal indices should equal 12 because there's 12 values. So we're saying, well, 12 equals what? 6y plus y plus 3y plus 2y plus y plus y plus y plus y plus 0 plus 2y plus 3y plus 4y. Now that should all sum up to be 24y. Now we just need to transpose the equation and move, so through inverse operation, so y equals 12 over 24, therefore y equals 0.5. Let's have a look at something a little bit trickier now. So we've got some value of agricultural production. So I think I went on to the Australian Bureau of Resource Economic Sciences website and grabbed this data. Now, agricultural production is notoriously seasonal. So we'll have a look at the seasonality. So what I did first of all, and I should have hidden some of this table from you to begin with, is I just grabbed this raw data around here. And you can see that we've got some raw figures, so March, June, September, etc. It's all in quarters, so we've got 4 quarters over 4 years. So what we're going to do is just calculate the mean for each year and create a seasonal index for March, June, September, December for each year based on that year. So you can see that I've just summed across and then divided down to get what my average year or average season for that year would look like. So for example, in 2015, an average season produced 19,565, whereas in 2016 an average season produced 21,491. In 2017, 22,759, and in 2018, 22,122. So we can see that the drought's probably been kicking in a little bit there because that's gone down a little bit, but otherwise it's certainly been increasing, hasn't it? So once we have found that mean for the year and for that season, what you're going to do is get that season and divide it by this mean over here, so this one over here. And so you can see that's what I've done. So 18,000 divided by 19,565. So the raw data for the season divided by the mean for that season for that year. And we're going to get a seasonal index, and we can use that soon to deseasonalize all the data. So if I were to just to pick one at random, let's just check what I'm doing. I have to have found the mean of all of these data points, which is going to be 22,759, and then I'm going to use that data point here and divide it by the mean season of that year to get my seasonal index. And that's what this is standing for here. So seasonal index for September for 2017. And you can see that that's 0.994. So it's a little bit down that for that example there. So we've got some average seasonal indexes, and what can we see? We can see that typically the sales were best in the December and September quarter, except for that one we just chose, funnily enough. So you can see that every seasonal index which is above 1 is above 100% for that season on average, and if it's below, it's going to be under 100%, so it's going to be less than average. So we have identified our trends. What we want to do now is to verify those trends. So what we're going to do is to calculate the mean for each index, and we just do that by working downwards. So we find the average of each of these, and we can see that on average a seasonal index for March is what, 0.981 or 98.1%. So it's 1.9% lower than normal. If I'm looking at the June, you can see that what I've done here is just calculate the average, and you can see, yes, that's what, 99.5, so it's a little bit less than the normal average season. This one is just a little bit more than the average season, and this is just a little bit more. So December looks to be the most productive quarter or most productive season overall for each of these. So we have identified the trends. Now we calculate the mean for each trend, and once we've done that, let's just check the reasonableness of the result. And that means that each of these indices here need to add up to 4, and they do. So that's a reasonable result. So we're then going to verify that trend that we looked at up here, and by taking the mean of each index, so verifying the trend by taking the mean of each index, which we've done, and interpret those results. So the March quarter, 98.1% of the average, or 1.9% lower. The June quarter is down by 0.5% on average. The September quarter is above by 0.8% of the average, and the December quarter is 1.6 above the average season. Once we have found those seasonal indices, we can deseasonalize the data and smooth the data out. And you can see what I've done here. I've created those seasonal indices, and I've just kept the raw data from the first bit of agricultural production, and we're going to use now these seasonal indices, and we're going to divide, and we're going to use this formula here. The deseasonalized value equals the actual value, so these are our actual values, divided by our seasonal index, which is this one here. So let's just run through this. So the deseasonalized value, and we can just pick this one at random. So 2016 for the June quarter. So what do we need to do? We need to look at the June quarter, the actual value, and you can see that that's what I've got here. And then I need to divide it by the seasonal index for June. So I need to divide it by this one. So that's what I've done here. Now, once I've done that, I have a deseasonalized value of $21,041. I might just do one other one just so we're all over it. So let's look at something a bit random over here. So we've got a December quarter for 2017. So remember, we want our actual value divided by our seasonal index. So our actual value divided by seasonal index, and we have a deseasonalized value of 21,818. Now I can present both of those, the raw data and the deseasonalized data, as a line, and hopefully that takes out a few of those unusual points, but it's not doing that well on this graph, I'm sorry to say. So I might do another one with you in Excel soon. Okay, can you calculate seasonal indices by using the average percentage method? Deseasonalize a time series by using a seasonal index, including the use of spreadsheets to implement this process, and solve practical problems. When you are good with that, please work on the mastery exercises for the day.